everyone, it's Dr. V, and we're going to be doing part 2 of the gas laws lab. I took a can, an aluminum can, and I added a few milliliters of water, but that's not the important part because this is not the liquids law lab, it's the gas laws lab. And I'm using heat to turn the liquid into a gas. So the gas that we're interested in part 2, is water vapor. Now, this gas has a certain temperature, and it's tempting to put the thermometer in there, but that's not going to work really well. I need you to go back and think of heating and cooling curves and phase changes. What's the temperature that a liquid turns into a gas if that liquid is water? You're going to estimate the temperature of that gas. You should have your notebook out. Your notebook should be filled and prepared just like we were doing this in lab. And you should be writing down this information. So the temperature of the gas, you estimate it. I'm going to let you come up with that number. And then I'm going to put this gas in the cold water bath. And the gas temperature is going to cool to be in equilibrium with the temperature of the water bath. So I need the temperature of the water bath. N is the last numbered mark, the thing I'm measuring passes or touches, and it's the 0. Should be close to 0. I'm going to do the big M. How do I get the big M? Well, the big M is the value of the subgraduates. I get it by taking the range divided by the spaces. 20 minus 10 is the range, and the spaces are 10, so that's 10 divided by 10. Each one of these is equal to 1. Those are the subgraduates. The uncertainty tool is the big M divided by the 10. So 1 divided by 10 is 0.1. This thermometer must be read to the 10th value even if the last digit is a 0. The number of unnumbered marks, the thing I'm measuring passes or touches, is 1. And now I'm going to do the imaginary marks, and it is right in the middle. And by the way, better be putting my eye protection on because I got water boiling over there. So I'm going to say that's 0.5. Here's the NMMUU you need for the temperature of the water bath for experiment 2 of the gas laws lab. Now I'm going to take my gas, which is filling up in the can, and I'm going to cool it to the temperature of this water bath, and you're going to make an observation. Ooh, and something rather dramatic happens. The can crushes. And we need to talk about that a little bit. What happened? By the way, that is not an explosion. That is an implosion. X, like exit, means to go out. When we start the experiment, the can has a little hole at the top, and the gas is occupying the entire volume of the can. It has a certain temperature. I'll let you estimate that. And it has a pressure. The particles are colliding on the side of the container, but it is equal to the pressure of the atmosphere because the atmosphere can be inside this can as well, pushing out. In fact, the atmospheric pressure is on the outside of the can pushing, and the water vapor is on the inside pushing out. Now we're going to assume that all of the gas inside of the can is just the water vapor. So we have atmospheric pressure pushing from the outside in, and we have water vapor from the inside pushing out, and the can is stable. But when we put the can in the water bath, the temperature inside the can goes down. That temperature is equal to the ice bath temperature, And that means the pressure inside the can is going to go down. But what happens to the pressure outside the can? The atmospheric pressure stays the same and the can collapses. You are going to estimate T1. I need to tell you what the pressure is of the atmosphere, and I measured it in the lab today. I measured it with a barometer. You have a second temperature, which is the ice bath that we measured, and you are going to calculate the second pressure. Should that number be greater than or equal to, or greater than or less than this number? We know it has to be less because the can imploded. That's all I have for you for part 2 of the gas laws lab. We'll do part 3 next. See you soon.